Welcome to this session. In this session, we are discussing about the factor affecting bias variations and the stability factors. In the last session, we seen that the Q point or the operating point of the transistor, and you know that the Q point can be vary from the cutoff point to the saturation point, and the variation of that Q point is depends upon the input voltage and the output voltage. Okay, and we can choose the Q point on the DC load line. Here, suppose we choose the Q point at the center of the DC load line. Okay, and if the circuit is working now, by choosing the Q point at any place, the Q point do not stick on that point. It can be vary, and it can be vary due to the some factors, especially the position of the Q point can be vary with change in the temperature. Here the variation of the Q point. Okay, now the bias stability is depends upon the thermal instability, which produce the cumulative increase of the collector current. You know that Q point is depends upon the collector current, that is the IC. Okay, if the temperature is changed, there will be the change in the collector current, and if the collector current is changed due to the temperature or another factor, then we can say that the stability of the circuit is not proper, or there is instability in the circuit. Okay, and if the temperature is increases, then collector current is increases. If the collector current is increases, due to that current, collector current, more current, the temperature is increases. In this way, due to the temperature, current increases. Due to the current, temperature is increases, and that process is continuing. And in that circuit, there is the chance of thermal instability, or we can say that the thermal runaway. And if the thermal runaway will takes place, the transistor will damage, and in the thermal runaway, the large collector current is flow, and the temperature is also the very large, or temperature is also the increases. So the collector current for the common emitter circuit is given by, it is depends upon some factors, that is the IC is equal to beta times IB plus ICEO. Here beta is nothing but the current gain, IB is the base current, and ICEO is the leakage current, that is the collector current when the emitter is open, that is known as the ICEO. So IC is equal to beta into IB plus ICEO, and that is also represented by, or beta into IB plus 1 plus beta into ICO. Okay, so this is the collector current. Now in this equation there are the three variables, that is the beta, IB and ICO. Okay, now let us see the stability factor, and the the stability factor is defined as the rate of change of the collector current with respect to the leakage current, that is the ICU. Okay, so this is the stability factor. So the stability factor is depends upon the beta and IB, and if we keep the beta and IB constant, then we get the change in collector current with respect to the ICEO, that is the leakage current, and therefore the stability factor is equal to the DIC divided by DICO. Okay, the stability factor may be expressed in the another way by using this equation, and here in this equation the IC is equal to beta times IB plus 1 plus beta into ICO, which on the differentiation with respect to the IC. Okay, so this equation can be written like this: 1 is equal to, if we differentiate this equation with respect to the IC, then we get this equation: IC divided by IC is equal to 1 into beta into DIB divided by DIC plus 1 plus beta into DICO divided by DIC, and that is equal to beta times DIB divided by DIC plus 1 plus beta into 1 divided by S, because this factor, you know that S is the stability factor, and stability factor is equal to DIC divided by DICO. Therefore, this is equal to 1 by S, and therefore we can write that the S is equal to 1 plus beta divided by 1 minus beta into bracket DIV divided by DIC. So that is the stability factor. Now let us see the beta sensitivity. Beta sensitivity of the circuit means the influence of B value, that is the beta value, on the DC operating point. Okay, this is the beta sensitivity. Let us see the beta sensitivity. Beta sensitivity is influence of beta value on the DC operating point. Okay, the variation of beta value are caused by the variation in the circuit operating points or the substitution of one transistor with the another transistor. Beta is nothing but the, what is the beta? Beta is the current gain, and the sensitivity of that beta value is depends upon the operating point. So variations of the beta value are caused by the variation in operating points or the substitution of the transistor. When we change the transistor, then its operating point also will be changed. Therefore, we can say that the beta value also change, and beta sensitivity, that is the K beta, is given by DIC divided by IC is equal to K beta into DIB divided by beta, or the K beta is equal to beta divided by IC into DIC divided by DIB. So this is the beta sensitivity. Now let us see the beta sensitivity for the different circuit, like as the common base and common emitter circuit. First of all, let us see the beta stability factor for the common base circuit. For the common base circuit, we know the collector current, and that collector current IC is equal to alpha times IE plus ICEO. Here the alpha is the gain, that is the current gain for the common base, that alpha is equal to IC divided by IB. So IC is equal to alpha times IE plus ICO, and here in this case the stability factor is equal to DIC divided by DICO is equal to 0 plus 1, and here the stability is equal to for the common base circuit, the stability is equal to 1. Now let us see the stability factor for common emitter circuit. And for the common emitter circuit, the collector current is given by IC is equal to beta times IB plus 1 plus beta into ICO, and DIC divided by DICO is equal to 1 plus beta, and here the stability factor S is equal to 1 plus beta. Now if the beta value of beta is equal to 100, then the stability is equal to 101. So this is the stability factor for the common emitter circuit. Okay, in this way, in this session, you've seen that the stability factor, beta sensitivity, stability factor for the common base, and stability factor for the common emitter circuit. Okay, thank you for watching this video.